Good afternoon. Nice to see some familiar faces here, so thanks for joining, thanks for coming in. My name is Leo da Silva. I'm a security SA here with AWS in Singapore. I've been with the organization for 3 years, and today, for the next 30 minutes, we're going to be talking about how can AWS help you automate some of the secure code analysis for your serverless and container-based applications, and how can we help you reduce the noise from low false positive rates, as well as reduce the time to scan and assess your applications within your code repo, and hopefully streamline the process to get your application deployed to production. That's our mission with this solution, and I hope you can take some learnings away from this. So let's start covering the basics. This is what 99% of the SDLC workflows out there would look like. You have the developers writing code on their favorite IDEs, and you name it, developers always find ways to come up with new tools and new things to do and play with. Kudos to them. So they write their codes, and then they push this onto like a code repo somewhere that triggers a build process. Once this build process finishes, hopefully you have some artifacts stored somewhere so security can scan it, right? So code review happens. You then push this to a low-level environment, SIT, system integration testing, QA, pre-prod, different companies adopt different low-level environments, and then you start your observability tools. So you start getting some logging, some monitoring, some metrics from your application so you can hopefully improve over time. That is what we expect to see in most cases. Even though this process has been around for a little while, we see two friction points here, especially when it comes down to engaging with security teams. The first one is around code review. There's different ways to approach this, right? We have customers doing peer review, which is quite important. We have some customers running tools, but manually triggering those tools. Some others have them embedded in the pipeline. But in reality, the current approach to the static code analysis can be quite cumbersome, especially because the results are not up to the standard to developers because they are noisy. They have a high rate of false positives, which takes away a lot of effort and time from developer teams to fix that. If you're a developer, you know exactly what I mean by that. And it's not necessarily adding value to the team straight away. So we have this problem, and it's been going on for a while. The second friction point that we observe is about the observability side. A lot of information that comes back from the observability stage either doesn't make sense to developers because has not been adopted using a meaningful framework, so information coming back is not readily available to be used, or the security team has no visibility about what's being reported from the application. So that's quite common that we see security teams and developers not necessarily align at that stage because they don't speak the same language and they don't look for the same metrics. Let me walk you through what I see in a lot of my customers here in Singapore and elsewhere when they deploy a DevSecOps pipeline in their organizations. And this is a really common pattern. And as you can see on the screen, I'm using a whole bunch of security tools because, again, this is what we see customers also doing out there. And they do deliver some value. Of course, that's a lot of progress from where we were probably a couple of years ago. And I'm super happy to see customers adopting, embracing this kind of security embedded in the tool chain, because that's definitely something that we should all be happy with. So let me walk you through what happens in this case. Customers, again, developers, they are working on their IDE locally. They're building all the code and writing everything they know of, pushing this into code commit, which is our repository for code in AWS. And as soon as they do that, we use some hooks that trigger build process. Hopefully this build process won't fail, and we're going to build some artifacts to be stored in code artifact. And then in this specific scenario here, you're going to see two tools being used. The first one is a static code analysis tool that will analyze your application code looking for vulnerabilities, looking for flaws in the logic, areas where attackers, being internal or external, can exploit and gain unauthorized access to the application or the data sitting behind the app. And the other one is an SCA tool, a software composition analysis. That is quite important. That's kind of a newish sort of tool in the security landscape. That is quite important when you talk about software supply chain security, SBOM. So a lot of customers are starting looking to software dependencies and packages that are not necessarily managed by the internal app team. So having an SCA tool in the pipeline is quite important, and I'm happy to see customers adopting this more and more. Then, everything going well, you deploy it onto your ECS staging environment there, and there's a second security tool that happens to be triggered. It's a dynamic code analysis tool. Notice that up until that point, I have not mentioned security as a function being involved, and that is quite real. A lot of organizations, security, because it operates in a silo, they either only get reports from the pipeline saying there's a critical vulnerability here, you better go there and check with developers because they're doing something wrong, they must, or they don't even get the reports, and developers need to figure out what to do, what's the priority, is this really critical, is critical in highs, if I fix that, is good enough. That is, again, a common pattern that we see because the reports coming from those tools does not necessarily give you the real sense of criticality, and they are quite noisy a lot of times. Why is this a challenge for security? There's a number of reasons why, but I'm calling out 3 of those reasons here. The first one is really time-consuming. It takes a lot of time from developers to fix those issues, called out by the DevSecOps pipeline. And that is due to one main reason. Our statistics that we collected from customers last year pointed that up to 30% of results coming from statistical analysis are actually false positives. So almost a third of everything that comes from those tools, they will not be real critical or high vulnerabilities. And as a developer, after you've gone through this 2, 3, 4 times, you start losing faith. And that creates a whole new paradigm of developers adopting security tools. And that's reality, and as a security practitioner, as I am, my whole job is to convince them that we can do better, and working together, we can achieve better results. So that's number one. A challenge that we see happening a lot is time-consuming, high-level effort, little value. The second one is when we talk about the existing tools that we see in the market, they lack some of the context that application teams require to make the findings from tools be really relevant to them. Again, vulnerability that's exploitable only externally, that is found on an internal app, is that really critical? Who is doing that correlation for you? How can you apply context to findings? There's a gap in the current situation that we see in customers. I'm not saying that all tools are the same, because they're not, but in general, that's a gap that we observe in the market. Third challenge, security tools are still, in the vast majority of cases, being implemented as a top-down mandate from security teams onto developers, which means they might actually use it, but they don't necessarily enjoy the ride. And for them to actually extract benefit from this, we need to be on the same page. Every time we have a top-down implementation of security onto what developers do, we know the lesson. We know exactly what happens. After time, we start seeing a reduction in the value provided by the tool, and developers try to find ways around it. So central DevSecOps pipelines, if they don't evolve with the needs from developer teams, they tend to present low business value to those teams operating on that. But Leo, you just said that we have 2 or 3 or 4 tools implemented in DevSecOps. Why do we see vulnerabilities showing up in production? Where do they come from? They come from two main areas. The first one is the source code, and that is part of what we observe in commercial software being deployed. I'm not sure if it's a well-known statistic, but up to 90% of software running in major enterprises out there, they are open source software. Only 10% of them are actually custom built, which means when we do deploy something in production, if you don't observe what happens outside your company, how those new packages and new components and libraries that you are leveraging to deploy your own application, are they still secure? Are they still safe? If you don't observe that, that will directly impact on the quality and security of your code, whether you like it or not, because it's outside your hands. So that's one major area, software supply chain security and the ability to keep up with what changes outside the scope of the work that you build on-prem. It is important for your overall security posture. The second area, of course, is what you control. What you build, the way you build today, might not be secure tomorrow, and we all know that. So how do we keep up with the ever-changing landscape of security? And moreover, how do you keep scanning things that you have already deployed to production? Those challenges, they are hard to solve. And that's why we believe we can try to help you with that. Let me talk about Inspector Code Scan. Inspector Code Scan is a machine learning, fully managed Power service that AWS released not long ago. I think we went preview in last week of February. In Singapore, we are available since last month. Why do we believe Inspector Code Scan can be a really nice addition to your toolchain? First of all, we don't sit in line with everything that you do. So the way you're deploying through your pipelines today, they don't need to change. We keep observing your serverless and container-based applications in a different way. Every time you deploy a new version of your Lambda function, for instance, or you push a new image to your ECR, we're going to trigger a scan. The second way that we're going to be scanning your resources is when we create a new detection mechanism to be able to pick different findings in your application code. And again, we already have solutions in place to scan packages and scan vulnerabilities on your layers of your ECR images or your Lambda functions. Here, I'm talking about the application code, the code that you write, different things, right? So those two artifacts, the two resources, Lambda and ECR, every time Inspector Code Scan finds a new issue with that, we push that onto Security Hub for better visibility of your security teams, as well as JSON reports that can be generated and sent to your developer teams. So we are trying also with the use of Inspector Code Scan to bridge the gap between security and development. Not only that, because we are using machine learning technology, the model is trained by us. Our own AWS application security team feeds back into this machine learning model to train it and improve it over time. We aim to have a 0 false positive rate from the results. And that's quite powerful because back to the problem I mentioned before, a lot of times our developers waste a lot of effort by sifting through results, and we're trying to minimize that by adopting machine learning in a really smart way to reduce the noise from those reports. So hopefully, every time we say there's something here, they will believe in you and they will try to fix it. And that is the mission that we are going for with this. Inspector Code Scan today covers the main languages that we see customers adopting out there. And that is actually a direct feedback from our customers to start off with those 3 languages. So we have Java, Python, and JavaScript. By the way, even though it's in preview, you can start using today in Singapore. So you can go back to your AWS accounts and enable this. I'll show you later on how to do it and what it looks like to operate code scan at scale. We also offer, as part of our detection mechanism, the ability to detect any deviation from our AWS API usage best practices, which means every time you use a function or you consume a service via an API endpoint that does not align with our own best practices, we're going to flag it and we're going to recommend you how to fix it. It's not just about this is wrong. It's about this is wrong, and this is how we think we can fix that. The other area that we cover as part of the spectacle scan scope, apart from OWASP and CWE, because that's bread and butter, right? That's what we expect, is how can you secure web apps, because they are the main use cases for container images running in our platform today, as well as sensitive information leakage via log injection or cross-site scripting. Those are the sort of the main areas where spectacle scan can bring a lot of value to you, looking at the code and using our detection mechanism to give you all those findings in a really human-readable way, easy to consume, and ready to be applied by your developers in their teams. Sounds awesome, right? But let me give you some examples of what spectacle scan can actually do for you, and what does it look like. On your left side, you see there's a hashing invocation there using MD5. All of us in the room, I would love to think that. All of us in the room know that MD5 is not a secure hashing algorithm. It's been deprecated for a little while. But in reality, if you're just doing MD5 to create a one-way hashing of something that's not sensitive, is this really a critical finding? Is this a real problem for you? I think in the greater scheme of things, you might have other priorities to fix first. So in this case here, even though it's an insecure hashing algorithm, we don't say it's a real vulnerability to your app. But in the second case, we have AES cipher that, as you all know, consumes MD5 as the hashing algorithm as part of the cipher for encryption. And because of that, we're saying you have a vulnerability, and this is part of the things that you have to fix as a matter of priority, because it's using MD5. So same thing, two different contexts, two different criticality assigned. That's what we're trying to do. We are trying to give you real information, real actionable information, so we can take back to developers and fix it straight away with a minimal effort involved. Another good example here of a security detection mechanism that we have. On the left side, as you can see, you have a log injection possibility, because there's user input being logged into stdl without any input sanitization. Pretty straightforward, right? It's not compliant, because we know every time you get a user input that gets streamed out as an stdl to a logging information, I'm not going to mention log4j again, I swear, but you have to be sanitizing what you're putting into your logs. On the right side, though, as you can see, we are doing the same thing, but there's a sanitization component before that log information gets into your SDDL. So we are calling out exactly the line number, exactly the user input, and what you need to change to make that piece of code compliant. It's about context, it's about recommendation, it's about best practices, it's about reducing the effort. That's what we're here to do. Another good example of what we see customers adopting out there, and that's a really interesting one. On the left side, let's assume you are rotating your keys. I expect people to rotate keys from time to time. So as you know, for you to be able to rotate your keys, you have to decrypt everything using your old key, and then encrypt using your new key. Not too long ago, AWS released a new function called re-encrypt, which means you don't have to have your data in plain text at any point of this process. So you can do one function and re-encrypt, which means you're going to be decrypting and re-encrypting on the fly. That should be the way you do that. Even though it's not a vulnerability, even though the function on the left side will work, that's not a recommendation. That's not what we see as a best practice. And we're going to cover that. We're going to call it out and say, in this specific line of code, you should not be doing this. We should be doing this way. And that will, of course, not only enhance and improve the security posture of your application, but give the confidence back to your developers that we are actually on the same page. Security and developers are actually talking the same language. That's quite important as well. Another example that's quite interesting. cross-site scripting. Again, quite common to happen. Unfortunately, it's still too common these days. On the left side here, we have another way, another example of user input not being cleared before it's used by the function. So we have a user selecting a color within this JavaScript, and this color name is being used by the application to define it. But there's no synchronization on input, which means the user can write blue, and he can write a whole bunch of SQL strings or embed another JavaScript in that form, and then you have an exploitable mechanism to do a cross-site scripting there, and you should be doing this way. How we do it? This is part of the recommendation that Inspector Code Scan will give you as part of the scan process. It's not just about pointing the error, it's about helping you fix it as quick as possible. And that's what we're trying to achieve with this. So Alexa, demo, please. It's not just about talking the talk. Let me show you how this solution works. So if you access your AWS console today, and if you are a user of AWS Inspector, as soon as you access this service on the screen, and bear with me because we are using the Wi-Fi service here, so be lagging, you're going to see these two banners. Let me just quickly touch upon them. One is Inspector Deep, Activate Deep Inspection, Inspector Deep Inspection. This is a new feature that we launched not long ago, and is during the trial period now if you want to try it. That gives the ability to inspect libraries and components that are managed by external library managers, like NPM and whatnot on your EC2 instances. That's a new feature that we launched not long ago, so have a look. And just yesterday, I think, we launched a new capability on Inspector where if you are a subscriber of the service, you can now look for CWE vulnerabilities on our database. So especially for heavily regulated environments, if you want to know if we are able to detect a specific CWE and you want to know beforehand, you can now use a database just to do a quick search and find out before actually a finding gets reported, which is quite cool. So let me walk you through what happens when you don't have Inspector Code Scan enabled in your environment. You're going to go to your console and you're just going to activate. Now you can see there's a AWS Lambda standard scanning plus Lambda code scanning option for you. The standard scanning gives you the ability to scan for packages vulnerability. It doesn't look at the code. If you want to look at the Lambda code, that's the option you have to go to. Similarly, if you just want to deactivate the surface action, deactivate, that's it. For everyone out there that has never used Inspector Code Scan before, it's free during the preview time, which finishes by the end of May. But even after preview, we do have a 15-day trial if you want to try it out and see for yourself. Just have a look at it. So back to the dashboard. Now you're going to see a new area in your inspector, which is code detectors for Lambda code scan. Of course, previous to that session, I created a vulnerable Lambda function to show you the results and show you what it looks like. So if I go to my Lambda function here, I have a function called my vulnerable function, quite creative. And if I click on it, I'll see all the findings, all the details, the ARN and whatnot, and all the different issues that this Lambda function code has reported and has been detected by Inspector Code Scan. I'm just going to open up one here just to see what it looks like. So once you open the finding on your dashboard, by the way, everything that you see on the screen here, it's available via API. And as a matter of fact, is a JSON file generated by finding. So if you have an external visualization tool, like a SIEM solution or whatnot, you can put this into your external tool quite easily. Of course, Security Hub is your native integrated with this. So looking at the finding here, the first thing that you notice is the criticality. So for this Lambda function, I have 3 high vulnerabilities found. Of course, one of them is my log injection, and this is the description. Not only that, it calls out the line of code where that log injection has been detected. This is really powerful. This is really good. And not only that, it gives you how to fix the problem. In other cases, it will give you a more generic explanation because that relates to a broader sort of issue. In some of the cases, it will be quite detailed, even with step-by-step processes about how to fix that issue. Another piece of information is what version of the Lambda function is being scanned. By default, we scan the latest version of a Lambda function, which means every time you update the latest version, it gets scanned, of course, so we keep up with all the changes that you have. And also, what was the detection rule on the Spectre side that got triggered to find out that we have a finding? As you can see at the top of the screen, there's something called Amazon Code Guru. And that's not a mistake. That is there because Amazon Code Guru, Code Whisperer, and Spectre Code Scan, all these machine learning security capabilities, they share the same training model, which means that everything that we learn from all different services, plus our own AWS application security team feeding back into the model, gets pushed out to this model used by you. So we're going to keep training and improving this model so you can get more benefits from it. And that is what we are trying to achieve, concentrating that detection engine across multiple services that are used to scan for vulnerabilities in code. Of course, they have different applications. They have different points of interaction with you. But in the end, we are trying to have a stronger, smarter model applied across all the application security landscape. So in this case here, we're going to show you exactly what the detection mechanism is looking for, all the rules that we have, so you can have a look as well. The whole rule library is available for you. You can study, you can analyze that. Also, what is CWE relevant to that? In a lot of cases, security teams want to know why we are picking up this issue and where this is coming from. So that gives like this bridge, again, from development to security and help them speak the same language. Of course, because Inspector Code Scan is integrated with Security Hub, that gives you assessment, a score metric against your security posture across your entire account. And if you have multiple accounts, you can roll up into the same Security Hub, keeping a tally on everything that's happening across your environment, and hopefully kind of give you like a full picture of the quality of your application security code across Lambda and ECR in multiple accounts. Another good thing that we have here I want to show you is we are only looking into Lambda functions, for instance, that are in use, which means you don't pay for Lambda functions that they don't get invoked. After 90 days, if the Lambda function do not get invoked, you don't have to pay for it. We stop scanning that function, which is really good, especially in these days where we are looking for more ways to cost optimize the environment. You only pay for what's being used. In my case here, I have 15 functions in total, only 3 being actively monitored. And one of them, of course, is my vulnerable account, AWS perspective. Oh, sorry, this one's here. And one cool thing that you see off the chart here is the kind of runtimes that we have in your functions as well. That should be able to give you a good indication of the quality and last time it's being upgraded, right? You should not have any Python 3.7 running there, which is my case, as you can see here. Alexa, next presentation. Okay, so key takeaways I want you to kind of use when you go back to your organizations and hopefully try out Inspector Code Scan as part of your application security toolbox. One is Inspector Code Scan leverages a machine learning capability and a rule-based logic, because of course we still have to use that. And we are targeting a very low, if not zero, false positive rate on all findings identified by the tool. And that is a big, big selling point, especially when security talks to development. please remind them that your mission here is not to add another super noisy report to their pile of things to do. It's about being a lot more assertive of things that have to fix and how and why. Number one, and this is paramount to the whole discussion, because in the end, we are trying to add value to the business, reducing time to deploy. That is what we're trying to achieve here. Second, in a lot of our tests, Spectacle Scan took a little, like really small amount of time to scan through the entire repo. We're talking about seconds and minutes. For medium-sized repos, we're seeing below 5 minutes, which is quite good. If you're using a statistical analysis out there, or even a dynamical analysis tool, you know 5 minutes is really quick for large repos, especially so. We are, again, trying to reduce the effort required to do that. We are always releasing new detection mechanisms, new detection rules. We are using our own AWS best practices, our own AWS application security learnings to help you identify those issues in your application code. So working with the internal application security teams give us a lot of knowledge that we can then share back with you through those detection engines. It's really important. Of course, as I show you, to enable Inspector Code Scan is really easy. It's a single click. There's not infrastructure being provisioned. There's no management of resources. You just need to enable that, and Inspector Code Scan will automatically start scanning all the resources, applicable resources, and show you results in a short amount of time, which hopefully will be exactly what you and your teams need to be successful. With that, I really appreciate the time that you spend here with me today. Of course, I can't forget to say, if you want to know more about Inspector Code Scan, if you want to know more about everything that I mentioned here, we have a lot of training sessions out there, free tools that you can access yourself. Please do so. There's some really good learnings to be made out there. And if you really enjoyed this session, please access your application, answer the survey, and give us some feedback. Okay? Thank you. Thanks for your time.